All right, now let's think about this problem. I have 10 elements in a set, and I want to have total functions from s to 0 and 1. The question is, how many functions are there, right? So again, let's think about a smaller case, right? Let's say that s is equal to 1, 2, and 3, okay? That's a terrible 3, you'll have to excuse me. All right, so I want to have functions from s into 0 and 1. And I want this to be total functions. So what I can do is I have 1, 2, 3, right? And now I'm going to pick the possibilities. So here's the first possibility. I'm going to say that that's 0, and that's a 0. That's one of the functions, right? It maps 0 to every element. Here's another one. 0, 0, and 1. That's a different function. Okay, what else could I do? 0, 1, and 0. 0, 1, and 1, and so on. And what am I really doing? I'm looking at all the numbers that I can build with 3 bits, right? And each bit can have 0, 1. We've done this problem before, right? So this is actually, how many can I do? 2 to the 3 equals 8. Okay, that is how many functions. I'm actually counting functions from one set to another set. Wow, right? And each function is actually represented by 3 bits. 0, 1, and 0, 1, 0, 1, 0, 1. That tells me everything about this function. That's pretty cool. Okay. By the way, Wolfram, who's a great physicist and who did a system called Mathematica, loves certain functions, and he actually gives them each a number, right? That's how he calls them. Function number 12, function number 53. And the way he gets those numbers is by doing the same kind of enumeration and then kind of taking that 0, 1, 0 in binary. Okay, and treating it as a number, and then that's his numbering scheme for functions. Okay, now by the way, you can generalize this, right? Let's say that S has 20 elements, and into the set A, B, C, right? Then how many functions are there? Well, let's see. I have 20 slots to fill, each one of them 3 different ways, right? So the answer, 3 to the 20th, okay? That's how you reason it out, right? Notice that it's not 20 to the 3, right? That would be the number of ways to map 3 elements into 20 different possibilities. All right, so we're counting functions. Suppose that I'm not counting total functions. I'm only counting any function. So for example, A could map to nothing, right? That's what a total function is. So how many different ways are there? Actually, this is really an easy problem. Again, I got to choose where does A go, where does B go, where does C go, and so on, right? This could be 0, 1, or nothing, which I'm just going to call nil because we like nil. Okay, this one is 0, 1, or nil, and so on. So I have 3 ways, 3 ways, 3 ways, 3 ways. The answer is 3 to the 10th. Okay, so basically, if I'm going to have partial functions instead of total functions, then just add an extra possibility, then nothing possibility, and you're back to the total function way of thinking. So that solves that rather nicely, don't you think? Okay, I have a set with 10 elements. I want different subsets with 3 elements. Different subsets with 3 elements. Okay, so I need to pick 3 things. Okay, how many ways can I pick the first thing? 10 ways, right? Because there are 10 elements. How many ways can I pick the second one? Only 9, because I've already picked one of them. How many ways can I pick the third one? 8, because I already picked 2. And then I have to be careful because these are subsets, so ordering doesn't matter, right? So once I have 3 of them, I got 3 in my hands. How many ways can I pick the first one? 3 ways. How many ways can I pick the second one? 2 ways. How about the last one? Only 1 way, right? So this is 10 times 9 times 8 divided by 3 factorial, okay? By the way, I just want you to notice, I'm just saying, okay? I just want you to notice that this is the same as 10 factorial divided by 7 factorial, right? Because I went 10, 9, 8, and then I I'm going to cancel that 7 times 6 times 5 times 4 times 3 factorial. Okay, so this here is actually the same as that. Okay, so yeah, that's another way to write that.